Hi, I'm Kanan, Chief Architect LiveRamp. I've been in the data industry for 30 plus years right now. I've been with LiveRamp for 5 years now. About LiveRamp, LiveRamp is a data collaboration company, and we provide trusted infrastructure that enables brands, publishers, and partners to connect and innovate with data safely, securely, and at scale. Our platform helps companies unify customer data, activate it across channels, and measure results with precision, all ensuring privacy and compliance. In a database terms, right, actually, so we let our customer touchpoint data from different sources, and they should be able to connect with each other. And we provide primary key for the customer touchpoint data so that they can identify and uniquely connect to the customer data, and then provide foreign keys for the data so that they can connect with their partners and rest of the ecosystem. So that is our primary business. And so the data size, as you know, ad tech space, the data is a lot of data, web impressions, signals, and coming from different spaces, right? The data is humongous. Okay, so we've been dealing with those data using our previous architecture with in a file-based approach. We stored it in a file format, a proprietary file format, thrift format, and we've been handling that data in a batch processes, right? Our business evolved and our problem statements started changing, and our business also was changing. We could see that 3 years back, we identified that we have to re-architect to survive the future, right? So we started working on re-architecting 3+ years back. So the main thinking is, how can we bring this processing closer to real time and also scale? So we've been assisting our customers, or we are preparing our customers to collaborate. That was our business at that time. And it slowly evolved with the recent acquisition. It evolved into, how can we, own the whole narrative of collaboration, right? So enabling the customers to collaborate was dealing with aggregate data in the database language. Whereas when I started working towards collaboration, there it's more transactional data, whether it's CAPI or whether it is signals, right, web activities. So it has become more transactional data. So aggregate data, for each aggregate record, we with the new collaboration thinking and our business change, we want to deal with more, like n times more transactional data. So we want to we are one of the biggest customers of Google GCP, and at that time itself, it's like we are pushing the limits of data proc and the limits of scale. So we want to find a way, how do we scale further? How do we get us ready for the world of signals and world of transactional data? So that is where we started thinking, and that's where we started looking at SingleStore as a solution. And I think last year I presented about how we went on, the whole selection process, and how we chose SingleStore to solve the problem. And I presented about how we architected, actually, like breaking the problems into smaller problems and scale, right? Instead of keeping that as a one humongous data, we partitioned it by domain. In the sense of defining a domain, we defined our domain as per customer, right? So we partitioned the data by customer, and the whole process of executing the data process by domain partitioning let us scale. And when I presented last year, it was like, yeah, we started doing it, and the scale, the whole process was evolving, and I presented that last year, actually. Right, so I think this is one of the slides from last year as well. I'm going to just recap, and so that I can start about where we are right now. So this is simplification, right? Our old process had a lot of steps, multiple copies of the data, and the whole process was taking days. And where we had to think about security of the data, lineage, and everything was a huge overhead, because compliance and security is a big deal for us, right? With that in mind, the whole system was like so bloated and so huge and multiple steps involved in processing that data. Whereas with SingleStore, we got the security, lineage, and all those things out of the box. And then we were able to achieve moving this whole thing into simplifying it. So our primary business, our primary job we did is about mostly involving joining three tables basically, right? So we had a customer touch point one, customer touch point two. We had our link table, which is an identity table, which can act as a link table and join those two data. So as primary thing is about joining tables, SingleStore worked out really, really good. And when we evaluated the object store support and other things came in handy, and that's what pushed us to the decision so that we went on last time itself. So like all these complex things changed into a simple SQL, right? So this was the design. We tested it, we made it work, and it really worked at the time. So now here we are. So this is where we are at this point now. So where the theoretical thing I presented with a little bit of migration started last year, we were able to push through a huge amount of data into this architecture right now. So we have around 40 plus petabytes of data going through our system at this point. I would say this is one of the biggest, real database-based data processing, I think. For sure, with SingleStore, this is one of the biggest data sets. So we have 40 plus petabytes of data passing through the system, and we are going towards 100 petabytes under process now. In that one of the applications, we already migrated 95% of the data processing. In another one, crossing 50% yesterday. So it's a huge migration actually, right? So a lot of steps involved and a lot of things involved. And we were able to successfully do. And in that process, we were able to save money, like tens of millions, the whole architecture, right? We are able to save money, and we were able to build IP on it. We have filed a few patents on how we are compressing our data and how we are handling our data with that actually, and we were able to get the SLA down from days to hours on the processing side. So those are all the successes we are seeing so far already. Right? So in this ecosystem right now, SingleStore, we have around 150K database. Yes, 150K databases in one of those side of things. So data at rest resides in GCS. So our object store. So in our case is GCP. In Amazon's case, it will be S3, right? So we are storing data at rest resides in GCS, and we made all the SingleStore clusters and ephemeral clusters. So they, based on the actions here, they basically they spin out a cluster and attach the data and process the data, and the cluster goes away or looks for the next action, which can be run from that cluster. And then the same thing goes on with the different steps. So the amazing thing that I'm super excited to share is the whole orchestration, whole process. Last week, we were using like around 350,000 virtual cores. Such a big ecosystem at this point right now. Right. With that, we were able to run most of our workload on Spark instances, right? So which is amazing cost saving and effective as well, because we are keeping the ephemeral part of the cluster and the flexibility of SingleStore to hold the data in object store. And GCS and Google was able to provide such an amazing GCS support, where we were able to warm up the SingleStore DB from the object store to the disk so efficiently and fast. So we were able to keep the clusters ephemeral and run this process. So what did we get out of this one, right? So we were able to get high scale, domain partitioned, in the sense of it isolated. So one customer's data is not going to impact the other customer's flow at all. So with that isolations, with that control we had multiple knobs to fine tune and fine tune the whole process. So right now, the running time of the process. For example, a customer sends a file, when it gets delivered, and how fast and how quicker, and all those things is defined by the FinOps. The finance decides, saying that, hey, for this customer, for this month, so I want to spend some more money and get it done in 1 hour, it can be done. Oh, this data is basically, it can wait for a few hours. It's not a problem, right? So then we can spend less money and process it slower and deliver it in a few hours. So that whole scale and the whole knobs or the controls we got in running the system is huge. And when we are dealing with such a diverse use cases and such a diverse data sets, varying from signals to the 1 week tolerance, SLA tolerance, marketing campaigns. So we can adjust that. So we don't have to be like always real time or always like 12-hour SLAs. So we got the flexibility, and we've got the flexibility of the scale. Now the limit of the scale is the limit of the cloud. So how much ever GCP can scale, we can scale. We are not restricted by anything on our own side actually. So the data can be anywhere here, right? As we showed in the data plane layer, data can be in anywhere in the data plane, and then we can process the data and deliver the data to the like few hundred destinations we have more efficiently and effectively, right? So this on the right timing, right? So when we got all this running and we were able to do that, we were able to get out of our legacy baggage we've been carrying and maintaining a system to a new system. And in this process, one of the amazing things we did is we did some org level changes as well. So with the org level, we were able to change the develop. Previously, we needed like Spark data engineers, high-end engineers to do all of it, like develop it, maintain it, and run it. Whereas here, we were able to separate it out. We were able to use our developers to develop things, develop business problems and business solutions, and we were able to isolate operations separately. We created a production engineering team where they can run the system, right? And then production engineering closely working with FinOps. So to adjust the speed or adjust the level of SLA, now it can be done by the production engineering team. It's an operational team, right? Where we can focus on 24/7 support and all those things, reducing on call substantially by the high level Silicon Valley engineers, where they can focus on business goals and business applications to deliver business value. An operation can be done by an operational team, which is away from developers, right? Serious developers. So, and then observability and more granular data across things and billing data points, right? So right now we have very granular billing data points now, where we can go by we can track by customer, track by file. So all those side effects of this whole thing was like humongous value. And so with all this, right, we got the data gravity, as my title said, like we got amazingly handle data and handle compliance, handle things isolated, right? So okay, now with the AI coming out in a bigger way, so we were able to very quickly, one of the first few companies in the collaboration world, we could come out and say, yes, we are ready. Because of all the efforts we've been doing for a few years, our data is in a more accessible place, right, with different controls and different things which I talked about. So with that, right, so we were able to bring in an IP. Now we have our own patent filed on the guardrails. So we built our own guardrails on top of it now. So where with that guardrails and the action-based architecture, so where the action is a queuing mechanism we use, where it can have all big data operations, which in behind that operation is where this ephemeral cluster-based SingleStore huge database architecture that process the data. With that, when we have a layer of guardrail layer with accessibility control and cache log in it, so we were able to develop MCP servers on top of it, so that the AI, agentic AI, or even natural language application, those type of things were able to access to our layer much efficiently. So as I said, as I talked about it last year, we are dealing with the data more. Now, this AI part and the enabling AI to access the data very effectively and efficiently is what we are doing right now. And when I maybe when I get a chance to talk next year, I'll have more detailed view of how we are dealing with the data and what is the scale of the AI and how we are able to monetize it so that we can say, hey, you know what? The collaboration right now can happen in the guardrails for that agentic AIs and other AIs are controlled and compliance-based access to specific set of data and how they can use it and what they can use it for. So now there are more and more reasoning models. This control layer and access to the data is going to be a big deal, right? Of course, there's two levels of AI things are happening, at least the way I see it. One is the way user interacting to data is something is changing for sure. All of us know that, right? So now we are not going to be like mouse clicking on a website. It may be a chat window where we are more natural language interface we are going to use to interact with our applications. So that is something already happening and it's inevitable. That change we are asked to adopt it, right? Second level change, that is second level thing in this whole noisy AI world is not changing is the data, right? So now we having custom models for all the use cases is not a meaningful thing, right? So because the bigger companies, bigger foundation models, they're spending millions and billions now on developing their models now. They're not just LLMs anymore. They are not, simple models. They are more reasoning models, right? So with those reasoning models and the investment they're happening there, building our customers model needs are coming down more and more. So what do we do, right? How we can use those foundational reasoning models to controlly, effectively access our data and reason and work with our data and provide the benefit we need, right? So that is where we are. That is where we are building those guardrails so that guardrails can enforce the accessibility control of the data for the reasoning models to work for us. Right. So that is what we are. That is where we are. And I'm super excited to share these learnings and share these things with you guys. Anyone who are re-architecting or architecting or thinking about changing your current system, feel free to reach out to me. I'll be happy to talk about it a little bit more in detail and explain this to you guys. Or even I can go in depth on any of this area. There's a huge learning, and we're planning to publish a few more papers also because it's a rare opportunity you get to work with hundred petabyte data and such a big ecosystem and to re-architect it. So I want that experience to be shared with a lot of people and shared with the industry so that the whole industry moves up when it comes to the accessing data and how we can make it available for AI. Okay. Thank you. That's all for me today. And thanks a lot for the opportunity. Thanks a lot, everybody.